See, we'll see today EMF equation of DC generator. What is the EMF equation? We have to derive this in the exam. EMF means voltage equation. What is the voltage developed in the armature? There are two windings. One is field winding and the one is the armature winding. What is the purpose of field winding? Anyone? What is the purpose of field winding? There are two windings. One is on the magnets, one winding is there. One is on the rotating part, one winding is there. In the armature winding, voltage is developed. Field winding is used to generate the flux. Whenever the armature is rotating, it is cutting the flux and EMF is developed in the armature winding, not in the field winding. In any machine, we are having only two windings. Okay. See here. See the equivalent circuit of the winding. Figure 26.42 you can observe. This figure 26.42 you can observe. Here, this is the armature. This circular part is the armature. Inside this circular part, one winding is there. Inside this circular part, one winding is there. This is the field winding. Totally two windings. Field winding is on the poles to generate the flux. Here inside this circular part, this is the armature rotating part. In the armature, one winding is there that is called armature winding. Whenever the circular part is rotating, this armature winding is rotating and it is cutting the flux. Here and here flux is there. Whenever it is rotating, it is cutting the flux and EMF is developed in the armature winding in this winding. So this is the load. When you provide the closed path for this winding, current will flow here in the load. Here, what is the current in the armature winding? IA. IA is the armature current. This current is coming at this point. This current is dividing in these two windings because these are parallel. In parallel, current will divide. IA will divide as IL load current and field current. ISH is called field current. Why it is called ISH shunt current? Shunt current is the field current. Shunt means parallel. See, this winding is in parallel with the armature winding. Here, one winding is there inside this armature winding. This shunt is parallel. That's why it is called shunt current or field current. Armature current IA is equal to IL plus ISH. IA is equal to IL plus ISH. Because armature current is dividing, coming to this node point and it is dividing in these two branches. Okay. What I am telling? Can anyone repeat? This is the equivalent circuit of the DC generator. Field winding, armature winding, and load all are in parallel. In any machine, you are having two windings. One is field winding, and the one is the armature winding. Where is the field winding? Can anyone tell?
Poles.
On the poles. Okay. Where is the armature winding?
Inside the circular path.
Inside the circular part, that is the armature. Okay, 1 second. See here, this is the field winding. On the poles, how many poles? One, two, three, four. On the poles, we are having the field winding. This is the armature rotating part. On the armature, coils are there. Coils are nothing but the armature winding. One, two, three, four, five, six, seven. I have told in the last class. What is the number of coils on the armature? Number of windings on the armature winding. Suppose 10 slots are there. In each slot, we are having two coils. What is the number of coils? 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, 10 are there. In each slot, two windings are there. Total windings are
5.
10 into 2. 10 slots. In each slot, two coils. 10 into 2, 20 windings are there. 20 coils will be there on the armature. When this armature is rotating, it is cutting the flux. Here, flux is there. Let us take this is North Pole and South Pole. Flux passes from North Pole to South Pole like this. Here also, North Pole, South Pole flux. Since we are having four poles, how many fluxes will be there? Four fluxes. P is 4. Number of poles P is 4. Total flux is 4 into 5. So 4, 5 is the flux in the here in this machine. Here flux is there. Whenever this armature is rotating, this armature conductor is cutting this flux. And voltage is developed in the armature coil, this coil, not in the field coil. Voltage is developed in the armature coil. Okay. Like this, voltage is developed in the armature coil, armature winding. So this is field winding or shunt winding. Poles on the poles, whatever that is winding is there, that is called field winding. And the winding that is in the armature is called armature winding. Totally two windings are there in any machine. Now we'll see the EMF equation or DC generator. Okay, second. Okay, see here. What is phi? Flux in poles. Flux per pole. If you are having four poles, P into P is 4. 4, 5. Total flux is P into 5. Total flux. Z is the total number of armature conductors. What is the formula for Z? Number of slots into number of conductors in each slot. That is Z. On the armature, what are the total number of coils? Z is the total number of armature coils. That is equal to number of slots into number of conductors per slot. In exam, we had to write this. For 10 marks, they lost. Z is the total number of conductors. Number of slots into number of conductors per slot. P is the number of poles. A is number of armature, number of parallel paths in the armature. Here A means I had to define for two types of windings. One is lap winding and the one is armature winding. Number of parallel paths. How we will get once we come to the class, I'll explain on the board. This I can't explain in the online. A is the number of parallel paths in the armature. Write down in your notes. There are two types of windings. One is lap winding and the one is the armature winding. Write down. I will define A for both lap winding and armature winding. Okay, let us see. I'll explain. I'll try to explain if you understand or not. See, there are two types of windings. One is lap and wave winding. What do you mean by lap winding and what do you mean by wave winding? First of all, this is the winding. This is the starting point. This is the ending point, finishing point of one winding, one coil. Let us take one coil. This is the starting point. This is the finishing point. Suppose if the starting point and finishing point is under the same pole, it is called lap winding. What do you mean by starting point and finishing point on the same pole? And wave winding means starting point will be, if starting point is under north pole, finishing point will be under south pole. This is called wave winding. Suppose if the starting and finishing both are under same pole, north pole or south pole, that is called lap winding. Okay. If you see here, this is the south pole, this is north pole. Let us take the first winding. The winding starting point is here. Where is the ending point? Here only, under north pole only. If the starting point of the winding, they take one first coil. This is the first coil. This is the finishing point. See, this is the starting point. This is the finishing point. Both are under north pole only. Suppose in the this is lap winding. Come to the wave winding. In wave winding, starting point is here under north pole for the same coil one is under, and the finishing point will be in south pole. Finishing point is connected in the south pole. That is called wave winding. Are you getting what I am saying? Let us take the first coil. This is the first coil. Let us assume starting point is here and the ending point is here. That means starting point and finishing point are under same pole. That is called lap winding. Suppose if the starting point is connected here and the finishing point I'm connecting here in south pole, then it is called wave winding. If the starting point and finishing point are under different poles, that is called wave winding. If the starting point and finishing point are under the same pole, under north pole, it is called lap winding, or under the same pole, south pole, starting finishing under south pole only. That is called lap winding. So here we are defining one parameter that is called number of parallel paths. A is called number of parallel paths. In lap winding, A is equal to P. Number of parallel paths A is equal to number of poles. But in wave winding, number of parallel paths is equal to P by 2. See here, I will show. Okay. For wave winding, the number of parallel paths is only two, sorry, wave winding. But lap winding, what is the number of parallel paths? P. Here A is equal to 2, here A is equal to P. For wave winding, number of parallel paths at any point is 2. But number of parallel paths A is equal to P here. That is for lap winding and wave winding. That is called number of parallel paths in armature. And what is N? N is the speed of rotation of the armature. With how much speed the armature is rotating. That is called N. N is in revolutions per minute. Speed is in revolutions per minute, RPM. And E is the voltage developed in the armature. E is the voltage developed in the armature. See these parameters. If you're hanged out, you can ask me. Phi is the flux in the poles, and P is the number of poles. Z is in the armature. How many number of armature conductors? If it is Z, Z is equal to number of slots into number of conductors per slot. Number of slots into number of conductors per slot. A is called number of parallel paths in armature. For wave winding, what is the number of parallel paths? Anyone? What is the number of parallel paths in wave winding? Just now I had told. A is equal to 2 in wave winding. In lap winding, number of parallel paths is equal to P. How many number of parallel paths? Suppose in the generator we are having 4 poles. What is the number of parallel paths? 4. Number of poles. A is equal to 4 here. P. Suppose if you are having 2 poles in the generator. What is the number of parallel paths? Are you listening? Can anyone respond? Suppose P number of poles in the DC generator is 10. What is the number of parallel paths?
10, sir.
10. Here, irrespective of the number of poles, number of parallel paths in wave winding is 2. Always it is 2. Number of parallel paths in wave winding is 2. Okay, that is A. Now we'll go for derivation of EMF equation of DC generator. What is Faraday's second law? E is equal to d phi by dt. Write down in your notes what I am telling. Average EMF generated per conductor is E is equal to d phi by dt. Write down. E is equal to d phi by dt. Take your notes and write down. E is equal to d phi by dt. Now I want d phi and dt. D phi is equal to phi into P. P is the number of poles. What is the total flux change? Total change in the d phi. D means derivative. Derivative means change. D phi is the change with respect to time. Dt means change in time. D phi means change in the flux. How much flux the armature is cutting? Whenever the armature is rotating, it is cutting the flux. When it is cutting the flux, there is change in the flux. This d phi is the change in the flux with respect to dt. So d phi is equal to number of poles multiplied by flux P into phi. This is the total flux generated in the DC machine. D phi is equal to phi into P. Now I know D phi. Now what is T? Within a period of T. So here I am substituting phi P by T. Write down in your notes. In the numerator you write phi P. In the denominator you write T. Write down T. Have you written? In the numerator you write phi P. In the denominator you write only T. So now your equation becomes phi p by t. What is frequency? 1 by t. Frequency is equal to 1 by time period. Now in place of t, substitute 1 by f. In place of t, substitute 1 by f. If you substitute 1 by f, what you will get? Phi p into f. 1 by t means this f will come to numerator. That is phi p into f. We are getting phi p into f. Okay. Now I will define the frequency. Frequency f is equal to n by 60. Number of revolutions per second. Number of revolutions per second is nothing but frequency. Write down f is equal to n by 60. F is equal to n by 60. Have you written? Now tell me the equation. What is there in your equation? Phi p f. F is equal to n by 60. Phi p f. F in place of f I am writing it as n by 60. This is the EMF equation for one conductor. EMF generated for one conductor. N, okay. What is N here? What is N? Speed of rotation of the armature. So this is the EMF equation for one conductor. If you want for total number of conductors, what you will do? We will multiply with Z. If you want for the total number of conductors, we will multiply with Z. Therefore, now equation is phi p n by 60 into Z. For one conductor, Z is equal to 1. For total number of conductors, what is the Z? Number of slots into number of conductors per slot. Z is the total number of armature conductors. Okay. Now see the EMF equation phi Z n p by phi Z n p by 60. Why they are dividing with A? Because we have to divide with number of parallel paths. If it is if it is wave winding, A is equal to 2. If it is lap winding, A is equal to P. For wave winding, A is equal to 2. For lap winding, A is equal to P. Now this is the complete EMF equation of DC generator. EG is equal to phi Z NP by 60A. So in exam we have to derive after this. How we will derive? Once again I am telling. See here. First you have to write the Faraday's second law. Faraday's second law is E is equal to d phi by dt. Write on the first step what I am saying. Once again you write E is equal to d phi by dt. In place of d phi substitute phi p. In place of dt substitute only t. Therefore now equation becomes phi p by t. Phi p by t. Now in place of t you can substitute 1 by f. 1 by f means f will come to numerator. Therefore now the equation is phi p into f. Phi p into f. What is the frequency? Frequency is equal to n by 60, number of revolutions per second. That is the frequency definition. Frequency f is equal to n by 60. Now substitute this f here. Then you will get phi p in place of f n by 60 I am substituting. Phi p n by 60. This is the voltage generated for one conductor. If you want total number of conductors Z, multiply with Z on the right side. Therefore, EMF total EMF generated is phi p n by 60 into Z. Phi p n by 60 into Z. After multiplying with Z, we had to divide with number of parallel paths A. A is called number of parallel paths. Now I am dividing with A. After multiplying Z by A, here we will get Z. Multiplication is Z. Division is number of parallel paths with A. Z by A. Okay. Total equation is now the total equation. What is the total equation? Phi Z n by 60 into P by A. If it is the wave winding, A is equal to 2. If it is lap winding, A is equal to P. P is going to be cancelled. P by A. A is the number of parallel paths. Like, this is the EMF equation of decision data. If you are hanged out, you can ask me.
So please could you repeat after multiplying with Z?
Okay. Here we are. This is the EMF equation for one conductor. If you want the total number of conductors, we are multiplying with Z. This equation, entire equation on right side, we are multiplying with Z. And we are dividing with A, area, number of parallel paths. A is called number of parallel paths. Why you are dividing with number of parallel paths means EMF voltage is developed for every parallel path. So total voltage we are having, but for every parallel path, what is the voltage developed? That's why we are dividing with A. So here we are multiplying with Z, total number of conductors, and we are dividing with A. This is the complete EMF equation of DC generator. Up to this, you have to write in the exam. Is it clear?
Yes, sir.
What is the number of parallel paths? Why you are dividing with parallel paths means for one parallel path, what is the voltage generated? I want. That's why you are dividing with A. Okay, because lap winding number of parallel paths is different, and wave winding number of parallel paths is different. For wave winding, what do you mean by wave winding? If the starting point and finishing point are under different poles, one is under north pole and another is south pole, that is called wave winding. Lap winding means if the starting point of the one coil in the finishing point of the same coil is under the same pole, that is called lap winding. Starting, finishing are under the same pole, that is called lap winding. So we are taking the number of parallel paths. A is called number of parallel paths. So we are dividing this entire equation with A. After multiplying with Z and dividing with A. That is the conclusion. 5, see here, after multiplying and Z multiplied, A is divided. 5 Zn by 60 into P by A. This is the complete EMF equation of DC generator. Is it okay? Still, if you are hanged out, I will explain on the board once after coming to the class. Okay, you can ask me in the class. See the problem based on this formula. This formula you have to remember. 5Zn P, 5Zn by 60 into P by E. Now, a 4-pole generator. 4-pole means P is equal to 4. Having wave wound. Wave wound means what is the number of parallel paths? A is equal to 2. Here A, they have given A. A value means wave winding. Wave winding means A is equal to 2. P they have given. P is equal to 4. That is P is 4, A is 2. Wave winding. If it is lap winding, A is equal to P. Okay. Has 51 slots, each slot containing 20 conductors. Now, what is the value of Z? Z is equal to number of slots into number of conductors in each slot. Z is equal to 51 into 20. Now, I know Z value also here. Z is equal to 51 into 20. Z is equal to number of slots into number of coils in each slot. This is Z. Total Z is 1020 coils. On the armature, we are having 1020 coils on the periphery of the armature. What will be the EMF generated in the machine when driven at 1500 RPM? What is N? N is equal to 1500 revolutions per minute. Now I know Z, I know N. N is 1500, Z is 1020, P is 4. Wave winding means A is equal to 2. And I want flux also. Assuming flux per pole is 7 milliwebers. Milli means 10 power minus 3. Therefore, phi is equal to 7 into 10 power minus 3 webers. So I know phi now. I know Z. I know N 1500 RPM. I know P. P is equal to 4. Here A is equal to 2. They have given wrong in your textbook here. A is not equal to P because it is wave winding. A is equal to 2. See, in the answer they have substituted correct. A is equal to 2. P is equal to 4. But they have given wrong here. Therefore EG is equal to 5 Z N by 60 into P by A. This is your answer. Any doubt in the problem? Is it clear? EMF equation or DC generator. What is the voltage developed in the armature winding? 178.5 volts. This is the voltage developed in the armature winding. So the Zoom meeting will end within a minute. So I'm ending the class. So in your notes, you write down the EMF equation. Note down the page number 915. BL Terja volume 2. EMF equation or DC generator. You have to derive in the notes. Tomorrow I'll see in the class. In online also you have to show by clicking on the video.